Hello, calculus fans. Okay, so let's try this one. We're going to estimate the area under the curve y equals x cubed between x equals 0 and x equals 1 using n rectangles over n equal sized subintervals. And we're going to choose the heights of the rectangles at the right endpoints of the subintervals. You should notice that the book has a calculation that's similar to this. They're using y equals x squared. Now let's introduce a little bit of new notation. We're going to use the notation r sub n to denote the area under n equal width rectangles with the heights chosen to be the right endpoint of the subinterval, Rn for right endpoint. And then, of course, analogously, we're going to have L sub n for when we use left endpoints. And of course, the n is going to denote the number of subintervals that we'll choose. Now, each rectangle is going to have width 1 over n, and when we do that, then our partition points, where we're chopping up these rectangles, they're going to be at 0, 1 over n, 2 over n, 3 over n, all the way up to n over n, because they're spaced apart by units of 1 over n. So these are the partition points that go into making these subintervals. Now we're going to be picking the right endpoints of these subintervals and plugging them into the function to get the heights. So we're going to evaluate f of x equals x cubed at the right endpoints. So the first subinterval goes from 0 to 1 over n. That means the first point that we evaluate the function at will be 1 over n. And then we go to 2 over n, 3 over n, and so on, all up to n over n. If we had done left endpoints, then we would have started at 0, and we would have ended at n minus 1 over n. Okay, so when we plug in those numbers, 1 over n, 2 over n, up to n over n, and we plug them into the function f of x equals x cubed, then we get these values, which are the heights of our rectangles. So that's going to give us an expression for the total area of the rectangles. So we add all of this up. Really, you should be thinking about distributing this 1 over n, because 1 over n multiplied by 1 over n cubed will be the area of the first rectangle. Then 1 over n times 2 over n cubed is the area of the second rectangle, and so on. It's just a lot easier to have the 1 over n factored out. Okay, a little bit of algebra here. If we take each one of these terms and simplify them, like this term here will turn into 3 cubed over n cubed. Well, they're all going to have n cubed in the denominator, and that can be pulled out with the coefficient here. And so I think what we're going to have is 1 cubed plus 2 cubed plus 3 cubed, all the way out to n cubed, and then we multiply by 1 over n to the 4th power. Now, this portion of it here, we can use one of those formulas that I talked about earlier to rewrite that expression. We have these summation formulas that allow us to sum the sum of cubes, sum of squares, things like that. So let's use that formula now. So essentially, this piece here can be replaced with this. A little bit of simplification, and this is our final answer. So what this represents is, what is the area under the rectangles made by choosing the heights to be the right endpoints using n equal-sized subintervals. Okay, that's all for now.